Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Maximum number of fish in a grid. Leetcode 2658. In this problem, we are given 0 indexed 2D matrix grid of size m into n, where each cell r, c represents a land cell if the value in it is 0, or a water cell if it contains a positive number. The number represents how many fish are at that position. A fisher can start at any water cell R, C and can do following operation any number of times. Catch all the fish at cell R, C and move to any adjacent water cell. An adjacent cell of the cell R, C is one of the following cells: R, C plus 1, R, C minus 1, R plus 1, C or R minus 1, C if it exists. And in the end, we should return the maximum number of fish the fisher can catch if he chooses his starting cell optimally, or 0 if no water cell exists. So the goal is to find the maximum number of fish the fisher can collect starting from any optimally chosen cell. Then in example 1, for the given grid, suppose fisher started from this position, then it can go on the right and collect one more fish. So this time they can collect 3 fishes, but it cannot go down or to the left because they are land cells. And these 4 fishes can also not be collected because we cannot go diagonally. So the total number of fishes fisher can collect if they start from this cell will be 3. Similarly, fisher can start from this cell, collect 3 fishes, then go down and collect 4 fishes as well. And now they see the land cell around, so they cannot move. So they will catch 7 fishes. Similarly, fisher can start from either of these 2 cells, say this one, collect 2 fishes, go towards left, collect 3 fishes, so total of 5 fishes, and now they are again locked by the land cell, so they cannot collect any more. And similarly, if fisher starts from this cell, they collect 1 fish and then go upwards and collect 4 more fish, so total of 5 fishes. And the maximum number of fishes the fisher can collect is 7, so that will be our answer. Example 2 is a bit simpler. So fisher can collect 1 fish either from this cell or from this one. So the maximum number of fish the fisher can collect will be 1. Now in terms of solution, this problem is very similar to graph traversal problems in a matrix, like those dealing with the islands or clusters in a grid, such as number of islands or max area of island. The difference is, instead of counting cells, we sum of the fish in each cell. To solve these problems, we can either use breadth first search or depth first search. Today we will be solving the problem with a DFS, but BFS will also work in case you want to try it out. Now the problem involves finding the maximum fish that can be collected from the water cells connected in 4 directions. So we will go through each cell in the grid to check if it is a land cell or a water cell. If it is a land cell, we will skip it as fishing is not possible here. For example, in this grid, we start at cell 00, which is a land cell. So we will skip it and move to the next cell at position 0, 1, which is a water cell. So if it is a water cell, we will perform the DFS to collect as much fish as possible by moving to its adjacent cells in the 4 cardinal directions, that is up, down, left and right. And during the traversal, we will keep track of the total fishes collected in the current connected water cell and update the maximum fish collected among all of them. For example, when we encounter 2 here, which is a water cell, we can start fishing here. So we collect these 2 fishes and then run the DFS traversal in the 4 connected directions. And to efficiently explore all the neighboring cells of a given cell in 4 directions, we can use a direction array, as covered in similar problems in the past. Each direction is represented as a pair of coordinates dx, dy, which denote the unit change coordinates for current cell x, y in the specified direction. In the directions array, we can have 4 directions defined as -1, 0 for going up, 0, 1 for going right, 1, 0 for going down, and 0, -1 for going towards left. So this array helps us move in the 4 cardinal directions. For each cell, we calculate the adjacent cell's position new x, new y as x plus dx and y plus dy respectively. Based on this, we may get some cells that are out of bounds of matrix. For example, for cell 0, 1, moving up would result in row as -1, which is out of bounds of the matrix. So we should ignore these invalid neighbors. So going up was invalid. Then we go to the right, and since it is a water cell, we will proceed here and collect the fish. So now number of fish we collect in this connected water cell becomes 3. And now from this cell we will explore the 4 directions. However, from this cell we can potentially revisit cell 0, 1, which we have already visited. So to avoid revisiting cells in the DFS, we use something called visited set. In this problem, we can use m into n Boolean matrix to check if the current cell is already visited. For example, when we visit the cell with fish 2, we will mark it as visited by setting the value true before exploring its neighbors. Another approach, if the interviewer is fine with temporarily modifying the grid, is to mark the current cell as a length cell, say by setting the value 0 here, and then undo the change once the DFS is complete. I have covered that approach in the past as well, but today I will be using the visited set or matrix in this case. So now at the water cell 0, 2, we try to go up, but it is out of bound. Then we try to go towards right. It is a land cell. Then we go down. That is also a land cell. And if we go towards left, the cell 0, 1 is already visited. We have explored all the cells around the cell 0, 2. So we will return. Now for cell 0, 1, we have already explored going up and towards right. So we will try to go down. It is a land cell, and we try to go towards left. That is also a land cell. So we have visited all the cells which can be visited from these water cells. And the total number of fish we can collect from the connected water cells is 3. Then we come to this land cell, so we skip it. Then we come to this water cell and collect 4 fish. Then we try to go up. We cannot go because it's a land cell. On the right also it's land cell. Then we try to go down, and this time it is a water cell. So we will collect 1 fish from there. And again we try to do the same thing for this cell. So we try to go up, but that is visited. We try to go towards right. That is a land cell, so we cannot go there. Similarly, we cannot go down because it's a land cell. If we try to go left, it is out of bounds, and we have explored all the cells around this cell. So we come back to cell 4. We try to go towards left, but it is out of bounds. So we have explored all the connected water cells, and the total number of fish we can collect from this connected water cell is equal to 5, which is more than 3 we have seen earlier. Then we come to this land cell, we ignore it. Similarly for this land cell, then we come to this water cell and collect 3 fish from the cell. Then we try to go up, but it is a land cell. So we try to go right, that is out of bounds. Then we go down, that is a water cell. So we collect 4 fish from there. Now total number of fish we have collected is 7. From this water cell, we try to go up. It is already visited. Then we try to go right. It is out of bounds. Then we go down. It is a land cell. Then we go towards left. That is also a land cell. So we return back and try to explore remaining directions from this cell. So we try to go left, and that is also a land cell. And now we have explored all the connected water cells. So the total number of fishes we will collect will be 7 in this case. Then we come to this cell. This is already visited. Then we come to this cell. This is a land cell, so we skip it. Similarly for this land cell as well. Then we come to 4. This is also visited. Then we come to this cell. This is also a land cell, so we skip it. Then we come to this water cell. So we collect 3 fish from there. And then we collect 2 fishes from here as well. So total number of fish we collect is 5. And finally we come to this cell, which is a land cell, so we skip it. So in the end, the maximum number of fishes we can collect from any water cluster was 7. So we will return 7 as our answer. Now in terms of time complexity, it will be O of m into n, where m is number of rows and n is number of columns, because we are going through each cell in the grid and visiting them only once. So because of this, the overall time complexity is O of m into n. And in terms of space complexity, it will be O of m into n as well, because we are using this visited matrix, which takes O of m into n space. And also when we are running a DFS, we are using the recursion here, but we can also use a stack. In both the approaches, the space complexity because of this will be O of m into n. Now let's jump into the code part. First, let's initialize our answer to 0 and get the dimensions of the grid with m as number of rows and n as number of columns. Let's also create visited matrix of size m into n to keep track of visited cells. And now we will iterate through each cell of the grid, and if current cell is a water cell and is not yet visited, We will perform the DFS to find the total number of fish in this connected component or in this connected water cells, and maximum among them will be our answer, which we will return once we are done with all the cells. Now let's create directions array with directions up, down, left and right, and write our helper DFS function. We will again pass in the grid, the visit set and current row and column. Now for each cell, we check if current position is out of bounds, that is R is less than 0 or C is less than 0, or R is greater than equal to number of rows or C is greater than equal to number of columns, or it is a land cell, that is it has no fish or it is already visited, then we will return 0. Otherwise, we will mark the current cell as visited and collect the fish from the current cell and explore all 4 directions and accumulate the fish count we find from the neighboring cells, and in the end return the total number of fish collected from this connected component. Now let's submit this code. Awesome. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.